Alright, so today we're going to talk about solving system linear equations. So the most important thing about this is that when you find a solution, what you're actually finding is the intersection between two lines. So if we look at, for example, let's look at example 4. Let's go all the way down to this one. If you look at this example here, you have a line here and you have a line here. So the first thing you have to do, you're going to have to graph this first, alright? So you're going to have to solve for y on the top equation. You would get, if you add y to this side, you would get 2x, and if you subtract 3 from both sides, you get 2x minus 3. Alright, so that's this equation right here. Right, if you solve for y in this equation, then you would get y is equal to negative 1/2 x plus 2. Alright, again, if you don't know how to solve for y, just come and talk to one of us and we can help you with that. So, what we're going to do here is we're going to actually graph each line. So we have 2x minus 3. So remember that the 3 is the y-intercept. In this case, the negative 3 is the y-intercept. And my slope is going to be 2. So I'm going to go up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, I'm going to draw a line right through all those points. And then now I'm going to graph this one right here. The y-intercept is 2, and the slope is negative 1 over 2. So I'm going to go down 1 and to the right 2. So down 1 to the right 2. Down 1 to the right 2. I'm going to go ahead and continue graphing this. Alright. So if I were to ask you, what is the solution to this system of equations, system of linear equations, the answer would be whatever the coordinate of this point is, that's your solution. Alright, so if we look at it, let's look at the coordinate of that point. The coordinate of this point right here would be 2. Alright, so we're going to go from here, we have 2, and then the y coordinate is 1. So again, the solution would be 2, 1. So remember, in your head, you have to know that every time I ask you for the solution, what I'm really asking is where those two lines intersect. Okay. So now we're going to go to a couple of special cases. So let's go back to problem number 1. Okay, so again, we're going to try to solve for y for each one of these. So if we solve for y, this one's pretty easy. Subtract 3x from both sides, and you would get y is equal to negative 3x minus 2. Okay, and on this one, if we try to solve for y, remember we would subtract 6x from both sides and then divide both sides by 2. Okay, so we would get y is equal to negative 3x plus 5. Okay, now we're going to go ahead and graph both of those lines. So y-intercept is negative 2. Okay, and now the slope is negative 3, so we're going to go down 3 and to the right 1. Okay, so we're going to, or we can go up and then to the left, which will make that slope negative. Okay, so there's that line right there. And now this one, the y-intercept is 5, so 1, 2, 3, 4, 5. And then the slope is the same as the other one, so it's down 3 over 1, down 3 over 1, down 3 over 1. Alright, so if we graph this, we get something like that. So if I were to ask you where do the two lines intersect, well, the answer is they don't. Alright, because these two lines are parallel. So again, if you have two parallel lines, then the answer to this one would be no solution because they do not intersect. Remember, the solution to a linear equation, to a system linear equation, is where they intersect. And in this case, because they don't intersect, then you have no solution. Okay, so if we go to a problem like number 2, okay, so if we go to a problem like number 2, this is another interesting problem here. You would solve for y, and when you solve for y, you would get, for the top one, you would get negative 1/2 x plus 5 over 2. Remember, 5 over 2 would be the same thing as 2.5, right? And if we solve for y on this bottom equation, we would get, let's see, we would get a negative 1/2 x. And it turns out that the next part is going to be exactly the same, plus 5/2. Now, obviously that would be negative 15 over negative 6, and if you reduce, you would get 5/2. Now notice that the lines, the equation of those two lines, they're exactly the same. All right, so we're going to graph them anyways, even though we know that they're going to be the same. All right, so my y-intercept is 5/2 or 2.5. So 2.5 is right here. Excuse me, it's actually right here. And I'm going to go down 1 and over 2. Down 1 over 2. Down 1 over 2, or up 1 to the left, 2. Alright, so that's what the graph looks like. Okay. Now the other line is exactly the same, but is literally right on top of it. So if I were to graph it, it would just be right on top, right? Now again, if I were to ask you, where do these two lines intersect? Where do the two lines intersect? And the answer is everywhere, right? Because they're right on top of each other. Now, because they're right on top of each other, there's an infinitely amount of points where they're intersecting, quote unquote, okay? So because of that, when you solve for y and you get the same line, then what you end up having is infinite solutions. Okay. So again, to review, all right, solve for y first. That's what you need to do. And then after you solve for y, you need to graph both lines, and the point of intersection is going to be what your solution is. Now, in case that you have two lines, notice if you look at both of these lines, the slope is exactly the same, which means they're parallel lines. All right, and notice that the y-intercept is different. All right, so again, the y-intercept is different, but the two slopes are the same. So therefore, you're going to have no solution, but you still need to graph it, right? So make sure that if I ask you to graph the system of equations, graph them, and then in this case, you have no solution because two parallel lines will never intersect. And then finally, if you have something where when you solve for y, you get exactly the same equation for the line, all right? Notice that these two are exactly the same. Then you're going to have infinite solutions because you're basically going to have a line laying on top of another line, okay? Now, if you kind of understand this, you can probably at this point go ahead and stop the video and then start on that part of the homework or move on to the next set of videos. I'm going to do just a couple more and just to make sure you understand it. Okay, so I'm going to do 5 and I'm probably going to do 6. So on 5, the top part, if I solve for y, I would get negative 4x minus 2. You can kind of see that. That one's not that bad. The one that I want to deal with is this one, right? How do I solve for this one? Well, on this part, first of all, I'm going to start off like I always do. I'm going to subtract 2x. I want to leave the y by itself, so I'm going to subtract 2x from both sides. And then now, if you have some questions about how do I get rid of this 2, remember, I want to leave y by itself, and I have a 2 down here. And because I'm dividing by 2, I'm now going to multiply all of this by 2. All right, so I'm going to multiply each term by 2. If I multiply this by 2, I end up with y. If I multiply this by 2, I get a negative 4x. And if I multiply negative 1 by 2, I get a negative 2. Now, notice again, before I even graph it, notice you have exactly the same equation for both of these, right? I have the same line. So I already know it's going to be infinite solutions. But let's go ahead and graph it anyway, just for practice. So we have y-intercept is negative 2, and the slope is down 4 over 1, to the right one, that is. All right, or up 4 to the left one. 1, 2, 3, 4. All right. That's the other line would be right on top of that. So therefore, this is actually infinite solutions. All right. We'll do one more, and this one's a little bit more normal, if you want to look at it that way. you solve for y, you would get 3x minus 2. And if you solve for y on this one hopefully it's easier to see for you. Excuse me. I said wrong color here. Right. You would get y is equal to negative x plus 6. Alright, so again, let's graph both of those lines. Notice that this one right here is 3x minus 2. Let's start there. My slope is 3. So when you have a slope of 3, you're actually going to go up 3 over 1. Alright, that is that line right there. I kind of missed it a little bit, but that's all right. Now this one is going to be 1, 2, 3, 4, 5, 6. The y-intercept is 6, and the slope is negative x, which is actually negative 1. So I'm going to go down 1 to the right 1. Down 1 to the right. So that is my line right there. And notice that my point of intersection is right there. Alright, so make sure you put enough points on those lines where you can actually see where the two lines intersect. So all I have to do now is figure out where those two lines intersect. So this is 2, 1, 2, 3, 4. So this is going to be, the solution is going to be 2, 4. And notice that I'm putting this in parentheses because this is a coordinate point. Okay? Alright, hopefully this helps. The other one, I'm not going to do it, but if you want to do it, it turns out that you don't have a solution because if you solve for y here, you would get two parallel lines. Anyway, go ahead and watch the next one after this one. Alright, so don't forget to watch the next section of this 3-1 study guide, which is actually on the back of this.